Systems Foundation. Here we have our NECO past question 7B. We are going to continue with our question 7B. Now, our question 7B is saying a bullet of mass 0.15 kg is fired with a speed of 213 meters per second into a wooden block which is at rest. If the bullet becomes embedded in the wooden block, find the common speed of the bullet and wooden block given that the mass of the wooden block is 1.2 kg. So this is a good question on mechanics, and particularly we are going to find this kind of question under Newton's law of motion. So we apply Newton's second law of motion to do this. That's law of conservation of momentum. So this is, we are going to go with the question. Solution. Now, the given mass of the bullet, the mass of the given bullet, let's call it NB. Mass of bullet, let's call it NB. As let NB equal to mass of bullet. We have to define it. Mass of bullet, and from the question, mass of bullet is 0.15 kg. So we look up to our question and see what else they are given. Now they said the bullet is fired with a speed of 213 meters per second. So let's say VB. So this will be the initial speed. So we have to take it as U, as UB, as initial speed of bullets. Initial speed of bullets. That's 213 meters per second. Now, what else are we given in the question? We look up to the question again. It said if the bullet becomes embedded. So but the bullet is stationary, is at rest. That's why they said bullet is at rest. That means the bullet is stationary. It's only the wooden block is stationary. It's only the bullet that is moving. Now, after when the bullet hits the target, the bullet becomes embedded in the target. Now, then we are asked to find the common speed with which the bullet and the wooden block move. So, but the mass of the bullet, the mass of the wooden block is also given. So that means since the wooden block is stationary, let's first write the mass of the wooden block. Let's take it as MW, as mass of block, mass of wooden block. So that's giving us 0.1, that's 1.2 kg. Then the initial speed of the wooden block, since it is stationary, the initial speed has to be 0. So we say UW equal to initial speed of block, and that will be equal to 0 meter per second. 0 meter per second. So now we are good to go. Then the final speed with which they move together is what they ask us to find. We can actually write that one out. Let's write it out. Final speed V of the two bodies that are connected together. So final speed is unknown. That is final speed. It is unknown. So now let's go on with the solution. We can go on with the solution. We are good to go. Now we have to combine the two parameters together. We combine all the parameters together. So according to the law of conservation of momentum, which is second law of motion, it's saying the final momentum or the initial momentum is equal to the final momentum, as the sum total of the initial momentum is equal to the sum total of the final momentum. So So we say initial momentum equal to final momentum. So we have to quickly derive a formula for that. Now, initial momentum will be mBUB. That's the momentum of the bullet, plus we have to add it with the momentum of the wooden block, which is mass of the wooden block times the speed of the wooden block. And that will be equal to mass of, so that will be equal to the final momentum. That will be equal to the final momentum. So final momentum, that's mass of the wooden block, mass of the bullet times final speed plus mass of the wooden block times final speed, since both of them are moving with the same final speed. So, and automatically this guy becomes 0 because our U is, our UW is equal to 0. So automatically this becomes 0. So we can say that MBUB is equal to MBV. So let's factor out B. So we can have this MW brackets V, since V is common to both of them. So now let's substitute what we have. Now MB is 0.15 times UB, which is 213. 213 equal to MB, which is 0.15 plus 1.2 times V, which we don't know, which we are looking for. Now, under this, we can quickly do some multiplication. 0.15 times 213. 0.15 times 213. That's 31.95. That's equal to 0.15 plus 1.25. 0.15 plus 1, that's 0.25. That's 1.25. Excuse me. 1.25 V. So this will give us 1. Oh, excuse me. That's 1.35. 1.35 V. So at the end of the day, we can make V the subject of formula here. So V will be equal to, if we divide both sides by 1.35, that's 1, that's 1.95 all over 1.35. So V will finally be equal to 31.95 divided by 1.35. 1.35, and that is 23. That's 23.6666 and so on. So that means finally V will be equal to 23.67 meter per second. That will be the final speed with which the two bodies are moving. And this is the end of question 7B. So you join us, follow us to the next video to enjoy our next video on question 8. So kindly like, share our video and subscribe to our YouTube channel. Thank you.